X-linked inheritance presents particular problems in genetic counselling, given that it can run for many generations without being spotted in a family. This next section deals with the classical issue of Duchenne muscular dystrophy running in a family. Selina, Dominic, welcome. My name is John Byrne. I'm the consultant in clinical genetics, and I've been asked to have a chat with you about, I think, Selina's family history. Can I ask, first of all, was it your idea or your doctor's idea that you came to the genetic clinic?
It was my idea.
Yeah, your idea.
Yeah, okay.
My idea. I asked to be referred. We are wanting to start a family as soon as possible. But I do have concerns in that my brother died at the age of 23 from Duchenne muscular dystrophy, as did my uncle, my mother's brother. And I know that it's genetic, but wanted to come and see you to find out the specifics of how exactly that works and to share that with Dominic. And really what the chances are of it being passed on to our potential child.
Okay. Before I go into that, I mean, are you thinking of starting a pregnancy in the near future? Are you pregnant already?
Not pregnant, don't think.
Okay.
But we're thinking about it.
All right.
Yeah.
Okay, fine. Well, you're quite right. Duchenne muscular dystrophy is a very well recognised genetic condition, and the fact that your mother's brother had it, and sorry, what was your brother called?
Michael.
Michael. I know from our records, in fact, the family had been looked after by us before, and that Michael had classical Duchenne muscular dystrophy, as did your uncle. So, in fact, that makes the counselling fairly straightforward, and I'd like to run you through that. But just, I'm going to take you back a step to explain how genes work, so it makes sense out of this. So, we get our genes in matching pairs, copy from mum and a copy from dad. And a gene's an instruction, tells you what colour your eyes are going to be, or how many fingers you need, or whatever. And there are several thousand of these genes passed on to us. Now, we have two copies of everything except the genes that are carried on the X chromosome. So genes are strung together on chromosomes like beads on a string. So you get two copies of every gene, you get two copies of every chromosome, with the exception of the sex chromosomes, where men and women are different. So women get two X chromosomes, men get one X chromosome and a little thing called the Y chromosome. And the Y chromosome is what made Dominic male. The problem is the Y, it kind of sort of makes you male, then lies around feeling proud of itself for the next 70 years. It doesn't do much. And so you don't have any significant number of genes on it. So it means that any gene on the X chromosome, a man only gets one copy of, whereas a woman has two copies of it.
Right.
Now, to balance the books, women actually switch off one or other X in each of the cells in their body. So, in fact, it's a little bit more complicated, but essentially you've got two copies, and so at least half of the cells in your body will be using a working copy if one of them's got a spelling mistake. Whereas if you're a man and you get a spelling mistake, you have no other copy. So every cell in your body will have the faulty copy of the gene, and you've got no cover. So you will get a full-blown problem. Okay?
Is that, in simple terms, if I happen to give birth to a boy, he is more likely to suffer from Duchenne as opposed to if we have a girl, because she would have.
That's right. And if you think about it, we know that your uncle had Duchenne muscular dystrophy and your brother also, so we can be confident that your mother was a carrier of Duchenne muscular dystrophy. Okay? Now, you are the sister, and so you inherited one or other of your mother's X chromosome. So it's a 50-50 chance whether or not you are a carrier or not a carrier. Okay? When you come to have your children, it's then a 50-50 chance again whether you pass on the working copy or the faulty copy if you are a carrier. Does that make sense?
Yeah.
So there's a half chance that you're a carrier, and if you're a carrier, there's a half chance of passing on the spelling mistake in the gene.
Right.
But then there's only a half chance it will be an affected baby because Dominic would have to make it a boy with a Y chromosome.
Okay.
So in fact, the odds are actually quite strongly on your side.
Is there any way we can find out if I'm a carrier or not?
Absolutely, yes.
Right.
And so what we will do is go back to the sample that we stored, because in fact your brother, with great foresight, asked to donate a sample of his DNA, and we're going to go and find the spelling mistake in the gene. And assuming we can do that, we will test you. even if we can't, we can use markers in his X chromosome to see whether you got the same X chromosome as he did from your mother. Yeah. So even if we can't find the precise spelling mistake, we'll be able to track down whether you are at high risk or not of being a carrier.
Okay.
And then if you are a carrier, then it becomes a straight 50-50 chance whether you pass on the working copy or not, and a 50-50 chance whether it's a boy or a girl. So there's a 1 in 4 chance that you would have an affected boy, a 1 in 4 chance that you would have a boy who was fine, and a 2 out of 4 chance that you would have a girl who may or may not be a carrier.
Okay.
Now the girls typically don't have a problem. Very occasionally they will show some problems because I told you it was a 50-50 chance in each of your cells which X you switch off. So you could have just by chance switched off all of the X's that carry the good copy of the gene and only used the X's that had the spelling mistake. And if that had happened, you would have had some muscle problems too. It does happen occasionally. So it does present us with a little bit of a problem on a pregnancy test, because if it was a girl who was a carrier, you might argue that, you know, that child might be slightly affected. But it's extremely unusual for a girl to present in childhood with a problem. You know, if anything, it tends to be a much later onset weakness and a much milder problem.
And you say they choose one, they switch on, so they ever change?
No, once you've decided in each cell line which one's on and which one's off, it stays the same. So you may, and it's called a mosaic, because if you looked at the cells in Selena's body, you'd find a 50-50 mix of some using the X that came from dad and some using the X that came from mum, and it sort of just mingled together.
Which is why you inherit personality traits from both mum and dad.
Well, yeah, but that's slightly different, because personality traits, of course, are determined by lots of other genes, not on the X chromosome.
Right.
So in fact, they aren't part of this story. But yes, so it's a similar sort of issue about mixing genes. You've got 2 copies of everything, so and you're a mixed of the two.